Okay, so let's do example 9. So in this example, guys, I have a cable that is unwound from a spool supported on small rollers at A and B by exerting a force T is equal to 300 Newton. All right? Compute the time needed. So I'm asked about the time, which means I have to use the kinematics equations needed to unravel 5 meters of cable. So I know, guys, delta S, or I know S. S should be equal to 5 meters, all right? So I'm unwinding, guys, this cable by 5 meters from the spool. If the spool and cable, both of them, the spool and the cable, they have a total mass of 600 kilograms and a radius of gyration KO. What does this mean? The radius of gyration around O, right? And this is equal to 1.2. And they are asking me, guys, that for the calculation, I can neglect the mass of cable being unwound and the mass of rollers at A and B. All right. So, guys, what are my inputs here? I know the towing force T. I know the unwound cable, which is 5 meters, so this will be S, and I need to find the time T. But, guys, if I know the radius of gyration around O, KO, then I can find directly IO. What is IO? It's M KO squared. This means since M is 600, KO is 1.2, so 1.2 squared times 600 is 864 kilogram meter squared. Alright, guys? So this is IO. If I know IO, let's try to find out if this equation can help me. The sum of moment around O is equal to IO times alpha. Now, what are the forces exerted on this disk? I need to show the free body diagram because I need to find their moments. I have, so what are the forces exerted on this disk with this cable? T, right? So guys, I need to find this T exerted on this disk. So that's why I took this T, not this one. And I know, guys, that this T in magnitude is equal to this T. What are other forces exerted on this disk? I have the weight, and I have the normal forces. All right? So what are these two normal forces? This is the tangent, guys. All right? And I know, guys, that the tangent, if I want to find the perpendicular to the tangent, it's what? What is the perpendicular line to the tangent on a circle? It is. So what line, guys, is normal to the tangent? It's the radius, yes. Which means, guys, this is an A. It's a no, I'm not gonna extend it to O, but it should be passing through O. So if you extend it in a dashed line, so this will be an A. And this will be an B. So they are both passing through O, because this means, guys, that NA and NB do not have any moment around O. all right? So the moments is equal to 0. All right, so the weight and the normal forces do not have any moment around O. The only force that has a moment around O is the force exerted on the disk from this cable, which is T. And what is the distance between T and O? It's given. It's the radius of the small circle, which is 0.8. All right, and don't forget that this T will do this moment of this rotation, right? So T times 0.8 is equal to 864 times alpha. Since I know T is 300 Newton, so from this equation, guys, why did I start with this equation? Because I know IO. So let's try if I can find anything from this equation. Yes, I can find alpha. All right, so alpha is 0.27 radians per second squared. Okay, guys, now what does this mean? If you take a look at this equation, the sum of moments around O is always equal to this T, and this T, Kareem, what is the distance from this T to this O, right? It's this distance here, and this distance here is given. It's the radius of this small circle. No, this T, no, how? This T here, the perpendicular line to this T is tangent to the circle. The extension of this T is tangent to the circle. In fact, you are pushing this cable with a force along this cable. Along this cable means, okay, along this cable means it's perpendicular to the radius of the circle, which means it's 0.8. Okay, now guys, I'm saying that this T is always constant. So this T is always constant, right? And this will give me that alpha will be always constant. So it's not, guys, like the previous example. This alpha is not alpha at the instant shown. It's always the same alpha because T is always the same T, right? I'm exerting always the same T, which means alpha is equal to constant. And this means, guys, that I have a uniformly accelerated motion. So why, guys, I thought about this type of motion because in fact, guys, I need to find the time. The time needed means I need to apply the equations of kinematics in terms of time, right? So since alpha is constant, then theta is equal to half alpha t squared plus omega 0 t plus theta 0. Now, if you take a look, guys, on this example, at the first instant, this cable was wound here, right? And then I exerted this T. When I exert this T, I'm gonna have a rotation, which means at T is equal to 0, when the cable is not unwound, this means, guys, that omega 0 is equal to 0. Whenever I do this towing force T, then the cable will be unwound, and then I'm going to have a rotation. This means, guys, that omega 0 is also equal to 0. Theta minus theta 0. So I can say also that theta 0 at T is equal to 0, the cable was not unwound, which means there is nothing unwound here, and theta 0 is equal to 0. So what is theta, guys? What I know is that S is equal to 5 meters. S is equal to 5 meters, and I know, guys, that S is equal to theta times R perfect Hassan, which means theta is equal to S times the radius of the small circle, all right? So the radius of the cable, guys, right, is equal to half alpha, which is known, t squared, then I can find t, right? So 5 over 0.8 is equal to half times 0.27 times t squared. Then I can find t is equal to 6.71 seconds. Okay, guys. So I don't need here sum of n and sum of ft, because in fact the question is not to find any force, it's to find the time. Now, if the question is then to find these two normal forces, then I have to what? I have to apply sum of forces in the normal direction and sum of forces sum of forces only in the normal direction. I think this will help me. Also, the sum of forces in the tangential direction, and then, guys, I can find them together. Question: